Good day everyone, I'm Janelle Pilayo from 12 Dalton and my topic is all about relate pressure to fluid density and depth. This presentation discusses how pressure in a fluid changes depending on its density and depth. It explains the scientific relationship between these quantities and shows how they affect pressure in real-life situations, such as underwater or in the atmosphere. This lesson aims to define and explain the concepts of pressure, fluid density, and depth. It also focuses on describing how they are related through the formula P is equal to P naught plus rho GH and to show real-life examples and problem-solving applications that demonstrate this relationship. What is pressure? Pressure is the force applied per unit area. In fluids, this force acts in all directions. The deeper an object is in a fluid, the more force or pressure it experiences due to the weight of the fluid above it. What is fluid? A fluid is any substance that can flow, such as liquids and gases. Fluids have no fixed shape and take the shape of their container. Since fluids can move and exert force in all directions, they play an important role in determining how pressure changes with depth. Density and fluid density. Density refers to how much mass is packed into a given volume. A fluid with higher density, like seawater, is heavier and therefore exerts greater pressure at the same depth compared to a less dense fluid, like fresh water. What is depth? Depth is the vertical distance below the surface of a fluid. The deeper an object is, the more fluid is above it, resulting in greater pressure. For example, a diver feels stronger pressure at 15 meters underwater than near the surface. And now let's proceed to the relationship of pressure, density, and depth. So the relationship between pressure, fluid density, and depth is shown by the formula P is equals to P naught plus rho GH. This means the pressure increases with depth because of the added weight of the fluid above. The pressure increases with density is because the denser fluids are heavier. And the gravity also affects how much pressure is exerted. In short, the deeper you go and the denser the fluid, the higher the pressure. So now let's proceed to our problem. A diver is swimming at a depth of 15 meters below the surface of the sea. The density of seawater is approximately 1,025 kilograms per meter cubed. Calculate the pressure exerted on a diver at that depth. Assume atmospheric pressure at that surface is 1.01 times 10 raised to the power of 5 PA and gravity is equal to 9.8 meter per second squared. So for the given is we have P is equal to 1,025 kilograms per meter cubed and the gravity is 9.8 meter per second squared and the H is 15 and the P naught is equals to 1.01 times 10 raised to the power of 5 PA. So the formula is P is equal to P naught plus P or rho times G times H. So the solution is P is equal to the value of P naught, which is the 1.01 times 10 raised to the power of 5 plus the value of P or the rho is the 1025 times the value of gravity 9.8 and the H is 15. So now for this value of P naught, so this value is converted siya sa kanang scientific notation. So we need to ibalik siya sa katong large number type. Ang kini siya is value sa P naught is ato na siyang gi-converted to scientific notation para ang tong the large number is ma-express siya into a small na siya. So now let's express this into a large number na. So we have 101,000 plus, let's multiply the 1,025 times 9.8 times 15. So we have come up the answer no 150,675 PA. So now we can add this too. So 101,000 plus 150,675 PA is equal to 200 1675 PA. And now, so we need to convert this large number into the scientific notation. So the answer now is 2.52 times 10 raised to the power of 5, which is or that 251.7 PA. So the calculated pressure of 2.52 times 10 raised to the power of 5 PA represents the total pressure experienced by an object or the diver at a depth of 15 meters in seawater. This total pressure is the sum of the atmospheric pressure at the surface, which is the 1.01 times 10 raised to the power of 5 PA, and the pressure due to the weight of the water above the PGH. As deep and fluid density increase, the pressure also increases. That's why underwater, the deeper you go, the greater the pressure you feel. Here, because seawater is quite dense, it adds the significant pressure, resulting in a total of 2.52 times 10 raised to the power of 5 PA. So that's all. So thank you for listening, guys.